Alright, so we have a bobsled. It is a 50 kilogram bobsled. That's its mass. It's at the top of the hill. It starts off with 0 speed, so it has 0 initial kinetic energy. And it's at some height, so we know that it starts off with some potential energy. And so that's potential energy due to gravity. So gravitational potential energy. As the sled is going down the hill, down the embankment, that potential energy is going to be converting into kinetic energy. And so whatever energy we start off with at the beginning will be equal to the energy that we have at the very end. So what we can do is we can go ahead and write out the equation for potential energy, and that's just mass times gravity times height, and we know all three of those variables, times height. That is going to go into, is going to be equal to the kinetic energy. And our kinetic energy is going to be 1/2 the mass times the velocity squared. So we still know what the mass is, and velocity is what we're trying to find ultimately. So you'll notice that if we set these two equal to each other, then the mass on this side, the mass on the right side, those are going to cancel out. And so our equation is going to simplify a little bit. That's just going to be gravity times height. That'll be equal to 1/2 of the velocity squared. And since we're solving for velocity, we'll move the fraction to the other side. So instead of dividing by 2, we'll multiply by 2. That is going to give us 2 times gravity times height, and that'll be equal to velocity squared. Now our goal is to find just the velocity by itself, so we'll move this over here so we have room. So we'll take the square roots of everything that's on the other side of the equal sign. So square root of 2 times gravity times height. And from there we just have to plug in our numbers. So v is equal to square root 2 times, our gravity is 9.8, and times my height is 161. So that'll give me a final answer equal to 56.17. And that would be my answer.